Good morning. Welcome to our first session. First up is Emma Hogan. Emma Hogan is a computer science and engineering doctoral student at the University of California, or California, San Diego, UCSD. Her doctoral research focus is improving college-level computer science in prisons. She has previously conducted research for her undergraduate thesis on the ideal role of technology in correctional education. She has taught introductory science several times through a higher education in prisons, an HEP program, as well as statistics. Her current research in the Computing Education Research Lab at the UCSD includes studying best practices for teaching computing in a correctional setting, incorporating culturally relevant pedagogy in college-level computing courses, evaluating emerging pedagogies such as live coding, and addressing concerns of students entering introductory computing courses. Upon finishing her PhD, Emma looks forward to continuing to research and practice teaching computer science in correctional settings.
Thank you so much. Let me share my screen. Can people see my screen with the slideshow? Okay.
Yes, we can see it.
Oh, good. Thank you. Thanks so much for that introduction. Thanks, everyone, for being here. I'm really honored to be here, asked to present at this conference along so many amazing speakers that we had yesterday and the day before. So yeah, again, I'm Emma Hogan, and I'm going to be talking about teaching computer science college courses in prison. So I'm going to go through just some abbreviations that might show up in this presentation. I'll try to say them all the way out when I'm speaking, but HEP, I'm referring to higher education in prisons. CS, I'm referring to computer science. STEM, I'm referring to science, technology, engineering, and mathematics. And then I just wanted to note that programming, I get some confusion sometimes depending on what audience I'm talking to because it has different meanings in the prison context when we're talking about programming opportunities such as educational programming in prisons versus in the computer science context where we're talking about programming as in writing code. So I'll try to be clear about the difference there when I'm speaking, but I hope that doesn't cause any confusion, and I'm happy to clarify at the end. So in this talk, I'm gonna first start out by doing some introductions to me, my research, and the course I've been teaching. I'm going to talk a little bit about the current landscape of STEM and computer science opportunities in prisons, and the challenges related specifically to technology access when it comes to teaching these courses. I'm going to do a short demonstration of what we call debugging in computer programming to try to illustrate some of these challenges for a non-computer science audience, or I'm assuming a majority non-computer science audience. So no prior knowledge in computer science is required, but I'm hoping I can show you what I'm talking about when it comes to these challenges. Then I'm going to talk about some strategies that I've adapted over my few years of teaching this so far, and some strategies with and without computers. And then I'm just going to briefly talk about my future directions with this work. So first, for the introduction, so like they said in introducing me, I'm a PhD student in computer science at University of California, San Diego. I'm finishing up my PhD, so I'm in my third year, and I have one more year left to finish my dissertation research. I do work in the computing education research lab, and our whole lab's mission is to study effective pedagogies, and by that we just mean effective ways to teach and help diverse students succeed in computer science courses. So computer science is one of the least diverse fields. There's a lot of it is mostly white men in the field of computer science, and at that, it's white men who come from, you know, privileged socioeconomic backgrounds and might have had access to computers and coding camps growing up and all of the resources that they needed to succeed in these courses. So my lab is studying how can we help diverse students succeed to make computer science more inclusive and diverse. And my dissertation topic specifically is focusing on improving computing education for incarcerated college students. So I'm focusing in at the college level in prisons right now for my dissertation research. And I do have an NSF grant for this work. I'm very grateful to have that. And I also received a Ford Foundation fellowship. So thank you to those organizations for supporting this. So now about the course that I've been teaching as part of this research. So I have taught an introduction to Python programming course twice so far. So I've taught it in the fall 2023, this past fall, as well as fall 2022. And I'll be teaching it again this upcoming fall 2024 for a higher education in prison program local to me in Southern California. And so this course fulfills the requirement for students who are currently, the program is only offering a sociology degree. So this Introduction to Python Programming course fulfills a requirement towards that degree. And it's also offered in a medium to maximum security facility. Many of the students on this particular yard where I teach, like lack exposure to modern technology, and the laptops for this education program were newly debuted at the time that I started teaching this course. And one important detail is that there's no code interpreter, and I'm going to talk about what that means in a bit, and that's hopefully I can show you with the demonstration how significant this is for teaching computer science. And then quickly, just I think the benefits of computer science education in prisons, there's many benefits to expanding this, but here are a few. So incarcerated students and their families, I hope, will benefit from gaining in-demand job skills for post-release, and also just more diversity of programs offered through higher education and prison programs. So, and I'm going to talk about that, but, you know, some people, not everyone is interested in computer science, just like on traditional college campuses, but some people are interested in computer science and STEM fields. And so having that diversity of programs offered, I think, could be really great. And also, the computing industry also really stands to benefit from expanding computer science education in prisons, because we are in desperate need of more diverse perspectives to better our tools and innovations to serve more people better. So right now, computer science opportunities in prisons are currently lacking. So according to some recent reports, STEM courses are scarcely offered in higher education and prison programs. A 2022 survey found that technology is limited or unavailable to many incarcerated college students. I know this is like a really broad statement. I also heard in Stacy, Tammy, and S's wonderful presentation yesterday that 92% of facilities, I think they said, had some form of connectivity. So this is changing quickly. We know that. But currently, for teaching computer science, it's limited in some pretty significant ways. And so one current challenge for teaching computer science is many incarcerated college students have no code interpreter. In other words, students are not able to run code that they write. And this causes some issues that I'm going to talk about. But I do want to acknowledge really quickly that you might have heard of some programs that I'm going to categorize as coding boot camps. Another way to like maybe describe this is like vocational programs for computer science. So some examples of these include The Last Mile or Unlocked Labs that was co-founded by people who were currently incarcerated and taught themselves how to code. And there's a few more examples of these popping up throughout the country. These are amazing programs. They've made major strides in terms of the feasibility of computer science in prison. So, now when people ask me, hey, is that even possible to teach like computer science in prisons? We have now many examples in many different parts of the country that this is possible, that people are getting the skills that they need in this vocational training kind of pathway to computer science. So I think my point that I'm trying to make is that, sorry. My point that I'm trying to make is that these programs are great. I think that we should also expand higher education pathways towards computer science and STEM fields so that these should be available in addition to these programs, similar to how they are outside of prison. So some roles in the computing field are filled by people who have gone through vocational training programs for learning computer science, and others are filled by people who have that traditional higher education with more knowledge of different areas in the field. So I think that we need both in prison, and also I think that these pathways through higher education are expanding right now because of the recent changes in Pell that other presentations at this conference have referenced. So so I wanted to acknowledge that there's great work being done there. This is my niche kind of happening alongside that, working on traditional higher education pathways to computer science in addition to those. Now I'm going to move to a quick demonstration of what I mean by the debugging process. And I'm hoping that this can show you what it means or how significant it is for teaching computer science when students don't have access to a code interpreter. So currently, my students don't have access to a code interpreter. At times, they haven't had access to a computer at all, which I'll talk about. But many incarcerated students around the country don't have access to a code interpreter. And so I'm going to show you kind of what that means in the context of introductory programming. So I know that many people watching this probably haven't seen Python code before, and I'm just hoping to show you, this is like an example of a program that an introductory programming student might write. This is in the Python programming language. So I've written a short program here where the program will calculate the area of a circle given some radius, and then it's going to print that result. I've written a line to test this program here using the area of 4. So let's say that I'm an introductory programming student and I've written this code and it has some errors in it. So if I'm a student on a traditional campus or with access to a computer with a code interpreter, then I would write my code and then I would run it and I would see that I've gotten an error here. So I know as an introductory programming student, I could look at this error and I'd see that I had invalid syntax at the end of this line 1. And so now I see in Python, we have to put a colon at the end of these lines, a particular type of lines. So I'd fix that error and then I'd run it again. And I get another error. And so I see that in line 3, some name is not defined. And so then I go back and I see that I meant to write area. And then I run this again and my program is working. So this is a very typical process of how computer programmers would write a program, especially as programs get longer. It's not expected to get code right on the first try, like in other disciplines like English, when you're turning in an essay. I mean, kind of similar to that, but when you're turning in an essay, hopefully you've corrected all of the grammatical errors and things like that. In computer programming, it's more typical to use running your code and finding the bugs, as we call them, which is why this process is called debugging, removing the bugs. It's more typical to run our code, look at whatever error comes out, and adjust based on that. So this is a really critical process in learning to program. And so just to summarize, this process that includes running code, deciphering the error message or an unexpected result, and then adjusting based on any of those errors is called the debugging process, and it's really critical for students learning. And so, oh no, there we go. So the problem is when students don't have a way to run their code, how can we simulate this debugging process for students, or at least how can we get them that critical learning of dealing with errors in their code in a useful way when students don't have a code interpreter? So this is a problem that I've been working on, especially as I've been teaching my courses. None of my students so far have had access to code interpreters, and I think it's still really important for these students to get access to computer science and STEM education. And even though I think these things are changing rapidly, here's some adaptations that I've come up with for dealing like specifically with this issue. So first, I'm gonna just outline the technology infrastructure that we do have in the program that I currently teach for. So I mentioned at the beginning that the students have individual laptops. These laptops were debuted the first quarter that I was teaching in fall 2022. And the laptops are equipped with a modified version of the Canvas learning management system. I'm sorry that I didn't specify that abbreviation at the beginning, but if some people might be familiar with the Canvas learning management system, I'll talk a little bit more about that. But if not, no worries. But otherwise, the students don't have access to internet resources right now. I think they're working on getting JSTOR, or that might have happened by now, but like that wonderful presentation yesterday was talking about was Stacy's work. So that too, now I should update my presentation, but they also are equipped with Microsoft Office, but again, no code interpreter. And in the first iteration of this course, I chose not to rely on Canvas or the laptops for any major portion of the course because they were so new to the facility that they kept being taken away, unfortunately. So there was really inconsistent access to computers at all. So that's why I'm going to go through first some strategies that I use to teach this introductory computer science course with that don't rely on computers at all. And then I'll talk about some with this most recent iteration of the course, this fall 2023, where I was using features that were available on the laptops. So the first adaptation that I'm going to talk about is just using this as an opportunity to stress conceptual understanding. So actually, recent work in computer science education has shown that a hack until it works, we call it mentality. If students are writing code that they don't actually understand and they just continually run it, maybe they go and Google the error that they got and then they try to fix it, and they just keep doing that debugging process without really having a good conceptual understanding of their code in the first place, is actually damaging for beginners in computer science. So we use this as an opportunity to stress conceptual understanding by splitting the homework grade between what we typically have in computer science, which is programming assignments, abbreviated here as PAs. I apologize for that. But we split them between programming assignments, where students are purely writing code to solve some problem, and problem sets, which had paper-based activities, which are obviously conducive to the prison environment, but there are paper-based activities that we use on traditional campus in computer science courses as well. So we just split the homework grade between these paper-based activities and programming assignments so that we could give students more opportunity to practice and earn points doing things like tracing the code, short answer questions, and fill in the blanks and things like that. So when the students, in the first time that I taught this course in the prison, when they didn't have access to computers at all in a reliable way for some major portions of the quarter, what I did was I had students handwrite their code, and then we came up with a system where I would pick up their code from the prison 2 to 3 times per week. I would transcribe their code, run it on my machine, print the output, and give it back to them. So this meant, and it was possible for me to go down there 2 to 3 times per week. So as you saw in my demonstration, I, ran my code 2 times. So I went through kind of 2 iterations, and then the third time when I finally had my code working, because there were exactly 2 errors in that code example that I showed you from the start. And so this can get tricky when students are only able to see the output of their code 2 to 3 times per week, because that short example that I just showed you where there were 2 errors in this course might have taken students an entire week to see that amount of code output from their runs, whereas a student on main campus, like in my demonstration, would have been able to see that within a few minutes. And so the demonstration was to show you how having less opportunities to have students run code causes challenges, because running the code and seeing the output only shows one error at a time. And it's very typical in an introductory programming course that students are going to have more than a few errors in their code that need fixing. So I came up with some adaptations specifically for that issue so that students could get more information per run of their code. So one way that I did that was to come up with really detailed grading rubrics. So this served a few purposes. One, I was able to give students partial credit for all of the parts of their code that they did get right. And they were able to more easily see what parts of their code, down to specific parts of lines of code, still might have errors that the output wouldn't necessarily show, because the output only shows the error that it first encountered. Another way that I dealt with this was creating what I called the common errors resource. And what this was like a running list of common errors that would appear in students' code, with an explanation, an example, and like what the error message might look like. So, and this is a similar program to what I had in that demonstration, if you want to read through this quickly, but basically what this did was it allowed me to give the students back their code annotated, pointing out every error that I saw, not just restricted to that one error that shows up in the code output when you run it. So if a student had handed in code, I was able to, for example, if they had this specific error in their code, I would just annotate their code with the number 22 wherever I saw that error, which pointed them towards this common errors list, which I could print out and bring to the prison, so that students could have the updated list. And so students found this to be helpful in the course evaluations, and I've ended up continuing to do this. I think this was a pretty good way to get students, again, just more information per run of their code so that they can fix more errors at once, hopefully. So now I'm going to get into some of the adaptations that I came up with that use the Canvas learning management system features. So this, like I said, the laptops were very inconsistently available the first time that we ran the course because they had been newly debuted. There were a lot more security concerns. They were more consistently available this past fall 2023. So I started using the Canvas features since students had more reliable access to the computers. So one thing that I implemented was hopefully hopefully I've convinced you now that being able to run code as many times as possible is important. So one thing that I implemented that was time consuming for the course staff or graders, but I think very worth it, was having students able to run their code daily by submitting typed code in a Canvas quiz that I left open. So I was able to run their code without physically going to the prison to pick up code. So that made the process quicker, so that I could take their typed code, run it, and then give the output back to them through that Canvas quiz. So I offered that to them once daily, and quite a few students took me up on this offer, so that they were able to get more code runs in than the first time I ran the course. Another thing that I implemented that used Canvas was something called code reviews. So this is basically in computer science, this is just a domain specific term for peer feedback. But basically what I did was I had a discussion board where students would post their code, a draft of their code midway through the assignment period, and then they would give feedback to at least 3 peers. So this is an example of a student putting a draft of their programming assignment code, and another student responding to them here with feedback. So this was another way for students to try to see errors. I had specific guidelines for how students should give feedback, where they were supposed to try to identify one thing in the code that they thought was definitely correct, and one thing in the code that they thought might be an error. and point the student towards a resource where they could find help with solving that error. Another thing that I did using Canvas was to have an open Q&A discussion board. I don't think this is specific to, computer science courses, but this was helpful in that it gave me even more opportunity to run code for students and show them the output. A lot of students would ask questions like, what happens when you do this or something like that. So I had the opportunity to, show them what that looks like when that code is run with the output and give an explanation behind that. So another way, and this is not computer science specific, but another reason that this was helpful was, if people asked questions during lecture that were outside the scope of the course, then I was able to say, hey, like, can you just put that on the discussion board so that we can stay on track for lecture? And then I could give them like a detailed explanation on the discussion board. So that's another way that I found that the discussion board could be really helpful. Okay, so I'm just going to end with my future plans. And this is my future plans, include just continuing to teach computer science in prisons more broadly. This is what I want to do for my career. I have some next steps with this work just in terms of like the scope of my dissertation, but I want to continue iterative improvements to this introductory computer science course for future offerings. Like I said, I'm going to be teaching this again in the fall, and then I'm hoping that someone will take over for me teaching this after that. I also am hoping to expand the variety of computer science and STEM courses offered. I'm working next year, hopefully, to offer a second computer science course. And then I also hope to expand to more prison settings to see how this works. As you all know, the specific technological, affordances and restrictions of prison environments are different everywhere right now. And so, I just hope to expand this to more prison settings so that we can see how this works within different restrictive environments. So that's it from me, and I'd love to take any questions. This is my email, website, and LinkedIn. And I just also want to acknowledge my research collaborators and thank them. That's Rochuan Lee, a student at UC San Diego, and my advisors, all in the computer science department at UCSD, Leo Porter, Bill Griswold, and Gerald Susai Raj. Thanks so much.
I love your passion. We have a couple of questions in the Q&A, and I am confident that there are questions in the live audience because I know somebody from JSTOR is sitting in there, like, eager to ask you some questions. So I will bring Amy on to do the virtual questions first, and then we'll go to the audience.
Okay.
Go ahead, Amy. Looks like Amy is not able to be on the screen. Oh, there she is. Amy, are we good? All right. I'm gonna take Amy. No, she's there now. All right, go ahead. Your microphone is still off. Off.
There we go. Okay. First question. One of the most common things I hear from the HEPs, the higher education programs in prison, is that they do not have access to computers at all. If they do, they don't have Wi-Fi. There's no doubt that computer science and IT are fields that are rapidly growing and are in need of more in the field, and diversity is important. But how do we bridge the gap when so many DOCs don't offer technology?
Mhm.
And they are limited to just their tablets? How can we push for the change to add the very important work you are highlighting? Furthermore, how do we press them on the security barriers that exist? So have you connected with Ithaca and just JSTOR on their research with educational technology?
Right. Okay. Yeah, I think so. I'll try to answer all the parts of that question. So I think the first part was how do we bridge the gap when DOCs are restrictive on technology. So that's definitely true. And one thing that I've heard anecdotally from people who have been doing this longer than I have, trying to teach computer science in prisons, is that higher education and prison programs have a hard time recruiting computer science faculty from their institutions when to teach computer science if the code interpreters and other resources aren't available. And I think that's maybe an issue that we can work on just by showing computer science educators that there are ways to teach computer science effectively that don't require code interpreters. It takes, maybe more work, arguably. Maybe it takes a bigger teaching staff to be able to give students more feedback manually by running the code. But whatever the case, it is possible. And I think that maybe instead of computer science educators um, computer science faculty waiting until prisons make this technology available, I think maybe that it needs to go the opposite way, that computer science teachers need to come in and start teaching computer science, show that this can be done and that there's a demand for it. And then I'm hoping that, the great work of, Ithaca, and I know there's also, other reports coming out talking about the necessity of having more technology for prison education programs. So I think there is momentum growing for that in the right direction. And I think that also, at the same time, we can't wait for that to happen to start teaching computer science and other STEM courses in prison settings. So yeah, I would say that's one way, is that we should start teaching now and find adaptations. And I'm hoping that the increasing access to technology. I know there are other people who are doing really great work on that right now, and so I think there's momentum for that as well. I think that also answered the connection. Have I connected with Ithaca SNR? Yes, I think their work has been super helpful. I cite their work in my research, and I'm really excited about what they're doing as well. And there was a second part of the question that I might be forgetting. I'm not sure if I've addressed it.
I mean the microphone.
I'm not sure where.
Okay, it's okay. Also, I can move on, and if that person, feel free to email me if I missed something.
Okay, and do you believe that residents acquiring and learning computer science skills will thusly help reduce stigma once they are re-entering reintegrated into society. How are the employers responding to this unique skill set?
Mm. Um, I am personally excited about the potential of people being able to go into computer science professions. To my knowledge, I don't think that there is work available yet. But if if anyone knows of any, please point me to it, because I'm always looking for work on, whether uh, whether technology companies are willing to hire formerly incarcerated people. And so, or rather maybe like whether they're more willing than some other more service-oriented professions, because or customer-facing professions. I think uh, there is the potential for that. To my knowledge, I don't know if we have that data yet, but I will say one thing that's come out of the work by Jessica Hicklin and her group at Unlocked Labs. I know that their Unlocked Labs work, they've actually been able to hire some currently incarcerated people. I think even ones that are presenting at this conference, who have been able to work for them, and also get work experience that could translate to the outside. So yeah, I'm sorry. I think my answer for now is that I'm really looking forward to seeing when we do have that data available, how the technology field and computer science field responds to and in their willingness to hire people who are formerly incarcerated.
I am confident that we have questions in the live audience. Whoever is there, make sure you unmute and take questions from the audience.
Yeah. Hi. First off, thank you so much for being so alert at 6 a.m. your time. I don't think I'm truly appreciate your energy you're bringing to the presentation. And I'm just curious, as I was hearing you talk about the reliance upon the interpreter, in my mind, I'm going, well, why doesn't someone create a program designed around an intro course, secondary course that acts as an interpreter that can live on a sole system, can be downloaded once, can stay there, and then identify the errors in the code as they're going through? Because if the rubric is so detailed, it could be predictive to say, all right, this is what the code should look like, or these options. But I know with coding, it gets so complex very easily. And so I'm just curious on if there's been any discussion around the development of that. And if not, that seems like a great opportunity to create something that could do that as a platform to make it so that faculty would be interested in teaching within the prison system.
Yeah, I think that's a really great point. Thanks for your question. And so I know that over at Unlocked Labs, they are, and this is a group of justice impacted people who are with this group who are creating these tools. I know that they are working on creating like learning management system software. And since they are from a computer science background themselves, I am, and I'm not sure that they're working on that right now, but I can see them working on something like that in the future. I think so. In my specific case, it really, I think there are ways that this could be implemented that would be, I think, so there are ways that this could be implemented that are incredibly secure, such as having maybe your code running like in a web browser. So like, since the students at the facility where I'm teaching already have access to Canvas, if the prison was willing at some point to just whitelist or give them access to another website where they could run their code in a web browser, you know, there would be ways to do it without any danger to people accessing the system, which is usually, you know, the argument from the prison administration side of why they don't want code interpreters on the computers. This has also been done. I mean, this has been implemented. There are code interpreters in you know, in facilities across the country because people are running full, you know, vocational computer programming programs in prisons right now. So there are ways that this has been securely implemented. I think that this really just comes down to when this particular facility or, you know, any given facility is ready to listen about these options. Right now, and you know, and I think so the facility where I'm working right now, this is a new program in general, and they haven't been willing to consider yet, you know, giving access to more things right now. I think that's quickly changing, and I think that things are coming out, such as, you know, code interpreters in a web browser and other work that's being created, such as the Unlocked Labs work on educational software specifically for prison settings. That's really exciting. And so, yeah, I hope that helps answer the question.
It does. Thank you.
Great.
Yeah, a question too. Okay. Thank you so much.
We
for
have
your
time for a couple more.
Okay.
Speak up, man.
Thank you so much for your presentation. It's actually informative. My question is, I want to believe that there are some courses that people that are incarcerated cannot actually take, like going into health field based on what I've read, that some of them cannot actually go into medicine. Some cannot go into financing based on what your crime is. Do we have something like that for computer science, since it involves coding, and we can use coding to do so many things? Is there any limitation on computer science for them?
And my answer, and so that's a great, thank you for your question. Not that I know of. So, yeah, sorry, I don't have a more descriptive answer, but not that I know of. Again, to my knowledge, right now, there is no computer science degree offered in a prison program in the country right now.
Okay.
So I think, but I know, like, for example, like the BARD program, I know offers a mathematics degree where they offer computer science courses sometimes as part of that. So I think we don't know yet. And so, but I really look forward to seeing that data when it does come out, and I would look forward to working on that problem if it does arise. But yeah, so my answer for now is not that I know of, and I'm sorry that I don't have more information. Yeah.
Thank you.
Good morning, Emma. Quick question. So I know you say, you know, computer science and actually labeling it as computer science and doing more than coding as far as writing code within the actual courses, right? What others items or specific areas would you suggest that actually are being taught within computer science? Is it like networking? Is it actually like hardware, that type of stuff on top or available along with the coding, or what? How would you expand that in your mind?
So I think, thanks for your question. Yeah, the ultimate goal would be to have a full computer science curriculum. And let me be clear. So before the 1994 crime bill, there was a computer science major, at least one that I know have offered through Wilmington College in Ohio. So in that prison program, they offered the full array of computer science courses, and some that you mentioned, like networking, hardware, software engineering, other things that come with the computer science majors, such as like algorithms, optimization. There are some other, coding courses and things that have to do with coding, like learning different programming languages, maybe, and data structures. So there was a program offering the full array of computer science courses successfully at that time. There's not one doing that anymore. And so I argue that that is possible and that we should start doing that again. And yeah, bringing in, I don't know if your question was like, what should we bring in next? I think, so my answer is all of it. But yeah, I think to specifically next year when we try to implement a second course, I'm hoping to offer kind of the next course that usually goes in the sequence towards a computer science degree, which would be data structures.
Okay. Thank you.
All right. Thank you so much, I really enjoyed your energy at 6 o'clock in the morning on a Saturday. And it was I learned a lot from this presentation, so thank you.